will be discussing differential equation, a short revision video on all the basic formulas related to differential equation. So let's start. So we'll start with order and degree of differential equation. So first is order and degree. So how we define order and degree? What is order? The highest order derivative present into the differential equation is called order. And what is degree? So it is the exponent of the highest order derivative when the derivatives are written in the form of polynomial. And it's important to note that degree may or may not be also defined, क्योंकि polynomial अगर नहीं हुआ तो उस expression के लिए degree define नहीं होगी, लेकिन order जो है वो always defined होता है. जैसे example के लिए d3y upon dx cube whole cube plus, let's say take it whole square, dy by dx is equal to 0. So if we see in this equation, then order is highest order derivative, so it is third order derivative, so order becomes 3, and degree in this it becomes 2 because the power of the highest order derivative is 2. So this is how we know the order and degree of a differential equation. So how we can form a differential equation? If an equation is given along with arbitrary constants, then in order to form differential equation, we can do is differentiate the given equation as many times as there are number of arbitrary constant in the given equation. So and then after differentiating, what we need to do is we need to eliminate all the arbitrary constants. Yeah, so we can write a point, second number, that to form a differential equation, differentiate as many times as number of arbitrary constants and eliminate all arbitrary constants. So now we have third point, how to solve differential equation. Solving differential equation. So there are few methods to solve. First we need to know that first is variable separation. So we can separate variable and we can solve differential equation. So it is variable separable. Second one we have is homogeneous equation. And the third one we have linear differential equation. These are main three types, and under these three types we'll study like subtypes. So first one is variable separable. So in this, what we need to do is we need to separate, like we have to write it as integration of fx dx plus integration of gy dy is equals to constant. Yeah, so if we can form an equation like this, then it is under variable separable. Now second one we have is subtype A, subtype B. Sometimes we have to use some standard differentiations and also some substitution in order to solve differential equation. For example, x dx plus y dy is equals to r dr. Next we have dx square plus dy square is equals to dr square plus r square d theta whole square. Next we have x dy minus y dx is equals to r square d theta. Also if we see anywhere x dy plus y dx, so simply we can write it as d of x of y. if we differentiate xy, so we get first into second का differentiation, the second into first का differentiation. So this is the same thing. So this is nothing but the differentiation of this. So we can write it as this. There are few more. So C point will write it as when the term of x square plus y square comes, then we can substitute x as r cos theta and y as r sin theta. And here we note that r and theta both are variables. So we can write it as so we can substitute this. So we'll get r square cos square theta plus r square sin square theta is equals to r square will take common, so we'll get sin square theta plus cos square theta, which makes up to 1. So this forms r square. So we can write as x square plus y square. No, we need not write. That's it. Yeah. So next we have see 1 star. Now next x dy plus y dx. Sorry, x dx. It's not dy. It's x dx plus y dy is equals to r dr. Similarly, we have x dy minus y dx is equals to r square d theta, where r is under the root x square plus y square, because we saw it's r square, so we can write it as x square plus y square is equals to r square. This was what? X square plus y square. We wrote it as like this. So r comes out to under root x square plus y square. So this is done. Now next point. No, in this only, tan theta is equals to y by x. So theta is equals to tan inverse y by x. Now that was done for the first this part. Now it was under C part, so it's D. We'll write as if the term of x square minus y square comes, then use x as r sec theta and y as r tan theta, and we'll write as x dx minus y dy is equal to r dr. Similarly, x dy minus y dx is equals to r square sec square theta d theta, where r is, we know that, under the root x square minus y square. And here, like there it was tan theta is equals to y by x, here we have sin theta is equals to y by x. So theta comes out to be sin inverse y by x. So this is done. Next we have so this was D part. E we have as when we get to solve differential equation of the type dy by dx is equals to a1x plus b1y plus c1 upon a2x plus b2y plus c2, where a1 upon a2 is equals to b1 upon b2, but it's not equal to c1 upon c2. This condition is important. So if this condition holds true, so how we can solve this is we can basically take common. So this and this, a1 upon a2, this and the ratio of this both are equal, so we can take common. So we can just write, we can take terms common from first two terms, from first two terms in both equation, in numerator and denominator, and solve further. Yeah. So also there is a subtype, or we can write it as f point. Similarly, same type, just condition is different. Dy by dx is equal to a1x plus b1y plus c1 upon a2x plus b2y plus c2. But here what the condition is, where a1 upon a2, or simply we can write as b1 plus a2 is not equals to 0. v1 plus a2 is not equals to 0. Sorry, equals to 0. Equals to 0. If this condition holds true, then what we can do is, in this type of questions, cross multiplication is done and then collect the terms of x dy plus y dx. We will write it as also, in this type of questions, we collect the terms, we cross multiply first, cross multiply and collect the terms of x dy plus y dx. This is the key point. Yeah, x dy plus y dx. We'll collect the terms of x dy plus y dx. Next we have homogeneous differential equation. Variable separation is over. Homogeneous differential equation. So first thing, what is a homogeneous equation? So homogeneous equation is a type of equation in which the sum of the exponents of each x and y terms in numerator and denominator is fixed. For example, if dy by dx we have been given as x square plus y square upon xy. So yeah, it is a differential equation, homogeneous differential equation, because the degree of every term is 2, 2, 2 and 1 plus 1, 2. So yeah, it is a homogeneous differential equation. Now next we have, also we can take example as dy by dx is equals to x cube plus y cube plus 3xy square upon x square y. So is it a differential equation, homogeneous differential equation? So yeah, it is a homogeneous differential equation. Each term has sum of the exponent as 3, so it's a homogeneous differential equation. So whenever we get a homogeneous differential equation, let's say dy by dx is equals to f of some xy comma y upon some g of x comma y. If we have some equation like this which is a homogeneous, so the standard approach to solve these type of question is, use the substitution y is equals to tx. Use the substitution y is equals to tx. Y is equals to t of x. So we will get it as dy by dx is equals to t plus x dt by dx. So we can replace dy by dx from x t plus x dt by dx, and wherever we have y we can replace it as t of x, and we can solve further. This is a general method, general approach to solve homogeneous differential equation. Now the last one we have as linear differential equation. This is the most important one. Most of the questions are asked from this linear differential equation. So what happens in this is, we have the standard appearance. we have it as dy by dx plus y times of some function in p. So we can write it as p of x is equals to q of x. So what is the solution of these type of equation? The solution is y into e to the power p of x equals to integration of q of into e to the power integration of p of x whole dx. So this is the solution of this kind of equation, and we need to be remembering this one. Yeah, so we need to memorizing this part, and also c is added. So this is and integration of e to the power px, no, e to the power px, just e to the power integration of px. This is called integrating factor. So this is the integrating factor over here, integrating factor, and here also we have integrating. This whole term is integrating factor. Oh, why we missed, no? Yeah, so integrating factor, this whole term is integrating factor, and similarly we have here integrating factor. So this is called integrating factor. So most of the theory is already done for the chapter. That is required for the solving of the questions. Rest, there are some other techniques that we'll learn while solving questions. So thank you.